Alright, next problem is a Ferris wheel problem. It says a Ferris wheel with diameter of 120 feet is 6 feet off the ground. It completes one revolution in 25 seconds. Express the height h of a seat closest to the ground as a function of t seconds after it begins turning. So you have a Ferris wheel that has, pretend like that was a nice circle, and it has a diameter of 120 feet, and it sits 6 feet off the ground. Okay, so if the diameter is 120 and it sits 6 feet off the ground, then the maximum height you could be would be 126. On your test there's going to be blanks just like this, okay? The minimum height you would be if you got on the Ferris wheel, since it's 6 feet off the ground, would be 6 feet. Alright, the next thing they ask you to do is find A. Remember, A for amplitude is max minus min divided by 2, which would be 126 minus 6 divided by 2, or 120 divided by 2, which is 60. So A will be 60. That's amplitude. K, the formula for that is max plus min divided by 2. So that would be 126 plus 6 divided by 2, which would be 132 divided by 2. Let's see, 2 goes into 13 6 times, with 1 left over. 2 goes into 12 6 times. So 66. Yeah, I think that's right. So K will be 66. Period. Well, it says it completes one revolution in 25 seconds, so I believe our period is 25 seconds. B is equal to 2 pi divided by the period, so B is equal to 2 pi divided by 25 seconds. So that is going to be what B is. It can't be reduced any, so it'll just be 2 pi over 25. They're going to ask you to graph the function also. Since the period is 25, when we graph, we'll do 4 tick marks. And I'm going to call the 4th tick mark whatever the period is, and the period is 25 seconds. The highest the graph goes is 126, and the lowest the graph goes is 6. The axis of wave is 66. So hopefully if you took 66 and added 60, the amplitude, that would give you 126. Or if you took 66 and subtracted that amplitude, you get 6. So I think we did it correctly. So I'm just going to kind of dot this over. It's not an asymptote, but it's just kind of our axis of wave. In the directions it said express the height of the seat closest to the ground. So I'm going to start closest to the ground here. The next tick mark I will cut the axis. The next one will reach the maximum. Next we cut the axis, and next we reach the minimum. So we graph it kind of like this. I like to do the graph before I write the equation because it helps me to decide what to write. Since it starts at the bottom, I'm going to call it a negative cosine curve. So it kind of has a generic form of y is equal to negative a cosine b x minus h plus k. There's no horizontal shift because I called it negative cosine, and I think I know all the other letters. I know A, and I know B, and I know K. So I could rewrite this as y is equal to negative, and we said A was 60, so negative 60 cosine. B is 2 pi over 25, and I'm going to say x, and then plus K, so we'll say plus 66. Now, if I wanted it to write it, because it actually said write it as a function of t seconds, perhaps it would have been a slightly better form. Instead of saying y, maybe I wrote function form of height in terms of time as negative 60 cosine 2 pi over 25 t for time plus 66. This is probably the best form. Right here, I would not take off any points if you wrote the equation that way. And there's our Ferris wheel problem.